Good morning students. Today we are going to discuss IIT-JEE NEET Foundation. The topic is heat. See, heat is a form of energy. See, it transfers from higher temperature to lower temperature. Heat is a form of energy. Heat is life sustainable energy. Once heat is emitted from the bodies like hot bodies, so the temperature, so if it is at high, so that is hot body. If temperature is low, cold body. Heat travels from higher temperature to lower temperature. See, temperature is the degree of hotness or coldness of a body, where the average kinetic energy of the molecules is treated as a temperature. So coming to in the heat, we have what is mean by heat. Heat is nothing but a form of energy. It is transit high temperature objects. So, and normally the appropriate term for the microscope energy, internal energy is heat. So you take heat here. The heat is related to the many things. See, like first law of thermodynamics. First law of thermodynamics is nothing but it is something like a heat and work. It relates heat and work. So the amount of heat Q is equal to, that is change in kinetic energy, change internal energy is equal to heat supplied minus work done. That is first law of thermodynamics. dQ is equal to du plus dW. The same thing you can express in terms of this. So thermodynamics is a subject which is branch under the physics, which deals with heat and work, the conversion of heat and work and other things. So there thermodynamics which is related to heat. Another one is heat, specific heat. What is specific heat? Specific heat is nothing but the amount of heat which is required for a unit mass of substance through unit degree rise in temperature. So Q is equal to Cm delta T, where C is the constant specific heat. The units are calorie per gram centigrade. The CGS units are calorie per gram centigrade. If you take SI units, kg per C, so joule per kg Kelvin, specific heat units. Heat transfer is nothing but rate of heat energy. The rate of heat, that is Q by T equal to Ka delta T upon D. That is heat transfer. See some heat examples you take. See, these are the heat examples you can take. There is a work done. See, heat is equal to, the work done is equal to pressure into change in volume. So temperature, what is temperature? The temperature is nothing but it is something like the degree of hotness or coldness or average kinetic energy. The one approach to the definition of the temperature is, see, if all are at, this is zeroth law of thermodynamics, thermal equilibrium. Thermal equilibrium means temperature remains constant. If there are two bodies, A and B are the two bodies, they are thermal equilibrium with each other. B and C are thermal equilibrium with each other. Then A and C are thermal equilibrium with each other. That is zeroth law of thermodynamics. Zeroth law of thermodynamics. A and B means A and B are at same temperature. A and B are at same temperature. So let us take B and C are also at same temperature. Then automatically A and C are also at same temperature. That is the simple law. What it is called zeroth law of thermodynamics, that is thermal equilibrium. That is called thermal equilibrium. The constant temperature, the body maintains constant temperature. So then coming to this is only zeroth law of thermodynamics. Just now I told you where A, B, C. So all those things where C, A and B are thermal equilibrium, B and C are thermal equilibrium, then A and C are thermal equilibrium with each other. So first law of thermodynamics, I told you it relates between heat and work, and see, second law of thermodynamics is it is impossible to transfer the heat from the body at lower temperature to body at higher temperature. It is impossible or very difficult to transfer heat from the lower temperature to higher temperature. So that is second law of thermodynamics. This is just a brief view of heat. So coming to the heat transfer. In the heat transfer, there are three types of transfer of heat. There is a transfer of heat takes place from one point to another point by conduction, convection and radiation. Conduction, convection and radiation. Conduction is nothing but, see, there is a transfer of heat. See, without they transport the, but it transfer only without transport the matter. So which can only transfer the energy from one place to another place. That is called conduction. Convection is nothing but by transporting the matter. So you are transferring the heat by transporting the matter. So that is convection. Radiation is nothing but the transfer of heat without any matter medium, like vacuum. If a heat transfers through vacuum, that is called radiation. Conduction, convection, radiation. These are the three types of heat transfers. See, conduction is nothing but, conduction is, if there is a conduction is a heat transfer by means molecular agitation. So due to the molecular agitation, the transfer, the material within a material without any motion of the material. I told you, no, without any motion of the matter. So material, so as a whole, one end of the metal rod is at higher temperature, transfers energy to the other end with the high speed of the particles. So that transfer we will call it as a conduction. The transfer only called as conduction. See, basic law of conduction, there is a, so Q by T, the rate of heat flow is directly proportional to area of cross section, and it is also directly proportional to change in temperature, and it is inversely proportional to length of the conduction. See, the length of conduction, it is inversely proportional. The rate of heat transfer is directly proportional to area of cross section. Rate of heat transfer is directly proportional to the temperature difference, and rate of heat transfer is inversely proportional to the length or length of conduction. So if you simplify this, Q by T is equal to A into T hot minus T cold, means hot temperature difference, like, okay, so body at higher temperature, body at lower temperature. The heat transfer, see, calculations can be done. So this is the different, the K is called here thermal conductivity. K is called thermal conductivity. The unit of K, if you write, the unit of K, see, the unit of K is nothing but thermal conductivity value. The K is equal to, you can hear rate of heat transfer is watt. See, watt per, see here meter square, meter get cancelled, here Kelvin will be there. So watt per meter Kelvin, watt per meter Kelvin is the unit of thermal conductivity. Thermal conductivity is denoted by K. So in that way you can write the units of thermal conductivity value. So thermal conductivity table, if you take, this is the thermal conductivity of different materials, like diamond, thermal conductivity value 1000 watt per meter Kelvin. I told you, no, just the unit of thermal conductivity is watt per meter Kelvin. If you observe here, the value will be 1000 watt per meter Kelvin, 1000 watt per meter Kelvin. This is the thermal conductivity value of diamond. Silver 406, like that. This is the different values. If you observe, different materials, different values are there. So steel thermal conductivity is 50.2. See, like that you can find out the thermal conductivity of different metals. So coming to the next, this thing, the discussion of thermal conductivity. The thermal conductivity, heat transfer, I told you there is a transfer of energy. So that is K delta T by delta X, the power per unit area. So before that we will discuss some calculation in thermal conductivity. See, there is a calculation part. See, calculation of thermal conductivity, if you take, so the heat conduction per unit time, thermal conductivity on area. See, for example, there is a wall surface area. If it is 100, you take 100 is the surface area, 100 meter square. Let us take 100 meter square is the surface area. Thickness is, see, let us say 10 meters. 10 meters is the 10 centimeters or 100 centimeters, you take 100 centimeter, 1 meter approximately. So thermal conductivity value So you can take thermal conductivity value. So you can assume that it is 200. The temperature of hot body, you take 100 degrees. The temperature of cold body, around 30 degrees. If you try to find out, see, this is the data is given. What is the rate of heat transfer? The rate of heat transfer, 100 degrees. Yeah, substitute values. Thickness is this much. Thermal conductivity, I think it is bigger value. Some value should be changed here. Let us take the 2 is the thermal conductivity. Then rate of heat transfer. We can find out actually, if you take those values, see the Q by T, the rate of heat transfer, if you try to find out. See, the formula is what? K into, see, T hot minus T cold upon length, distance D. See, K value. What is the K value we are given? The K value is 2. Area is how much? Area is 100 meters square. See, temperature difference, 100 minus 30. 100 minus 30. So upon, see, length, distance, the thickness, that is nothing but conduction. The conduction value is also 100 centimeters, 1 meter. If you try to find out, so 2 into 100 into 70. So it means 140 into 100. So approximately it is 14,000 watts. You are going to get this. This is the value, okay, supposed to get. So like that you can do the conversion and you can do the calculations also. So this is about thermal conductivity, heat transfer. The heat transfer examples you take. The heat transfer examples. See, there is heat transfer mechanisms, heat transfer conduction examples. So after conduction there is a convection and radiation. So we'll discuss in the next video convection and radiation and some more examples. So thank you very much. Thanks for watching this video.